Welcome to the 8th video in the Electrostatics series for grade 11s. In the previous video we were looking at the proportionality relationship between the electrostatic force between two charged objects and the product of the charges on the objects, as well as the inverse square proportionality between the distance between them and the electrostatic force. We summed it up. We stopped with this where we said F is proportional to the product of Q1 and Q2, the charges of the two, the magnitude of the two charges, and inversely proportional to the square. Now this leads us to Coulomb's law, and Coulomb's law states the following: the force of attraction or repulsion between two charges is, now we're going to have a look at this and break it down, is directly proportional to the product of the two charges. So is directly proportionate to the product of the two charges. Let's go have a look at that again now. And is inversely proportionate, sorry for my spelling, to the square of the distance between them. So, sum it up in a formula. It looks like this: the force of attraction or repulsion is directly proportional to the product of Q1 and Q2, the charges, and inversely proportional to the square of the distance between them. We're just going to add another one now, which is K, and K is Coulomb's constant, which is 9 times 10 to the 9 Newton meters squared per Coulomb squared. So there we go, and we're going to now apply it. If I've got two spheres, let's hope that these look something similar, identical spheres A and sphere B. Alright, we've got these two spheres, and each of them have a charge. Sphere A has a charge of 2 microcoulombs, and sphere B has -6 microcoulombs, and the distance between them is 100 millimeters. Alright, the first thing that we do is we go and write these amounts into their standard SI units. So 2 microcoulombs is 2 times 10 to the -6 coulombs, and -6 times 10 to the -6 coulombs is Q2, and R is equal to 0,1 meters. So now we've got them in the SI units. We're now going to substitute straight into this formula of F equals to K Q1 Q2 over R squared. K is 9 times 10 to the 9 times 2 times 10 to the -6 times 6 times 10 to the minus 6. Now I know some of you are saying, well, why aren't you putting the minus in? You could, but please note that this force is scalar in the fact that force A is attracting force B. Sphere A is attracting sphere B with this same force over here, as it's the same amount that sphere B is attracting sphere A, because it'll be attraction because they're opposite. Now if it was the same charge, it'll be repulsion. So we can put a minus, and if you get a minus answer, you know that it's going to be attraction, and if you get a positive answer, you know it's going to be repulsion. But I already know that it's going to be attraction because they are unlike charges, so I don't put anything in there. I'm then going to go 0.1 squared, which is going to give me an answer of 10 microcoulombs. If I got this right, let me just see. No, wait, let me just put this in to my calculator. (10,8) microcoulombs, 10,8 newtons of attraction. Be very careful. A common mistake here is many students forget to put the squaring effect, and then be careful of your entry into your calculator. Maybe I should just show you my calculation. Let's just do this calculation and then you can actually view it. I'm going to go 9 times 10 to the 9 times 2 times 10 to the 6 times 6 times 10 times 6 times 10 to the minus 6. See, that's the type of error we must not be making. All over 0.1 squared. Let's hope that I've got everything right, and it looks right. So it's 10,8 newtons of attraction, because if I left that as a minus there, if I left that as a minus over here, I would have had an answer of a minus there, and that should tell us that it's a force of attraction. So that's Coulomb's law in words, how we come about it, as well as the application. What you're going to be required to do is exercise 11.1 in class, and you can raise up any questions that you have over the last few videos out of that exercise.